This conference will now be recorded.
Can you hear me? Hello? Can you hear me, Mahinder? Am I audible? Hello?
Yes, Shiva. Yeah, you can. I can hear you.
Verify about daily claim summary, new query with our SQL query, right, Shiva? That's what you're saying?
Okay. Now, okay, in last class, we have created one IAM user with some admin, with some EC2 full access permissions. and how we can create a IAM user through Terraform, how you can automate the process. So here, if you want to automate the process, there are examples here. Say Terraform IAM user. So here IAM user is a resource here. So this is going to take username and tags. So along with that, you are going to give policy also. So policy directly you can give policy JSON document, or you can write a JSON directly here. So here this is the argument reference, name of the user, path. The default is root path, and force destroy tags is optional. And once the user is created, the outcome will be URL, ID, name, tags all unique ID. Now let us create one folder, and for the sake of this is user creation, and along with user creation we have to create a policy. Okay, policies are designed by AWS. And what is a policy? Policy is going to decide what a user can do, whether a user is able to perform EC2 full access, okay, S3 full access, and whether you wanted to give admin access, what kind of policy, what kind of right, what kind of privilege you wanted to give. That is also one resource. Okay, policy attachment, that is also one resource attachment. How to define policy, how to define a user, and how to attach policies. And there is one more resource here, Terraform IAM user policy attachment. Here this is policy attachment here. So in the policy attachment, you have to give to which user you wanted to give this policy ARN. Okay, so policy ARN should be given here, and test attach. And this is IAM policy. This is only going to create policy name, and policy JSON document. You can directly write JSON document, or you can attach that. Or in the place of ARN, you can write built-in policies like EC2 full access, admin, S3 full access. You can give directly built-in policies also. The ARN of the policy you wanted to apply. Now, let us verify one policy here. Let us take one example. In D drive, I have a IAM test, and from here I will open Git bash. From here I will open Visual Studio Code, and from here first of all I am going to Terraform, destroy, auto. I have defined policies for other students, so I will show that. Now let us open this document. Now this is a IAM.tf document. Here this is resource AWS underscore IAM user. Okay, here this is a username which you can give. Name of the user will be new user example, and a resource we are creating access key here. So for which user you are creating access key? New user. New AWS IAM user dot new user. New user is a username dot name. And after that we are displaying access key and secret key. So here to display secret key and access key, we are using output blocks. Okay, we are using output blocks. So the first output block is going to display secret key. Secret key from this one. ACCK dot secret, and ACCK dot ID means this is access key. And after that we are attaching a policy. Okay, so this is policy attachment document. Resource AWS IAM user policy attachment, and user 3 S3 full access. And to which user you wanted to create this policy? New user dot name. You are creating new user dot name, new user example. And what is policy ARN here? Policy ARN is going to take ARN. Okay, this is a built-in one. Okay, this is a policy that is defined by AWS. Here we are not writing any JSON file. Using JSON file also you can write a policy, or otherwise you can use built-in policies. Amazon S3 full access. Okay, so for built-in policies, in the last class I have shown. Okay, like EC2 full access, AWS admin access, S3 full access, RDS full access. These are the built-in policies. Now let us create this user. Okay, so when I create this user, a user will be created, and a secret key will be displayed, and access key is also displayed, and at the same time one policy called S3 full access will be created, and that will be attached to, okay, new user dot name. And let us try this. Terraform apply auto approve. Okay, here this is access key, and secret key will not be displayed because it is sensitive data, right? So this will not be displayed. Okay, and if you go and verify in AWS, okay, a user called new user will be created, and let us go and verify in AWS, and go to IAM, and go to users. It is a new user example, new user example, and let us refresh this. This is created just now itself. So if you click on this, and if you select permissions, so are you seeing Amazon S3 full access here? And if you want to know about security credentials, okay, in the access keys, okay, if you click on create access key, secret key, both are generated here because we have given AWS IAM access key also we have created, and secret key access key will be displayed as the output. So this is how you can create a user with uh, built-in policies like S3 full access, admin access, with anything you can create. Now here, username you need not to give directly. Okay, if you want to give a username, okay, from variables, so you can take a file like okay, here I am giving like inputs or variables, inputs dot df. Define a variable name is username. You can define a variable. Description, equal to enter username. Let us comment it. I will show later. First of all, let me destroy this user. So to destroy this user, first of all, you have to deactivate secret key. Deactivate it, and now destroy it. Now we are going to do same user. We are going to create same user by using variables. Done. Now we are going to use variables now. Let us uncomment it. And here I am going to define one file. Okay. So before that, let us do some activity here and here in this variable file in this iam.tf, and rather than writing direct name, okay, you can take like variable dot username, and username you can give directly from keyboard. Otherwise, okay, you can define a file terraform.tf vars file, terraform.tf vars. Okay, so in that file directly you can give the input terraform.tf vars, and here you can write username equal to hello. So here username equal to I am going to write something like John, and in inputs.tf I am going to write something like type equal to string. Okay, I don't write anything here because it is going to take value from terraform.tf vars file. Now let us run this. Okay, directly I have given value in the terraform.tf vars file, so that it does not ask anything. So if you go and verify it here, refresh it. Are you seeing John is created here? Okay, your terraform.tf vars is going to contain all inputs. Whatever variables we have given in input.tf file, for that variables you can give values in terraform.tf vars file. Okay, have you got my point, Mahinder? Hello, can you hear me? Hello, can you hear me? Is my voice audible? Am I clear to you? Am I audible? Okay, let us deactivate secret key. Deactivate and let us destroy this. ID equal to John. Okay, John has been created. John has been destroyed. This is how you can create a IAM user along with some permissions. So here Terraform .tf whereas file contains inputs for variables file that is defined. Okay, so in our example, okay, in our directory folder, I have defined a file called terraform.tf where I defined a username. Where I defined a username. Now, another important thing you have to know that this is nothing but Terraform lifecycle. Terraform lifecycle. So when it comes to Terraform lifecycle and during a resource creation and destroy, okay, so you can perform certain activities here. Suppose uh, at the time of creating a resource, okay, so Terraform can check some prerequisites, and when the prerequisite is matching, then only the resource will be created. And after creating resource also, okay, it can check for some condition, that is post condition, pre-condition. And suppose if there is a database server, and when you are destroying that server, and in the lifecycle meta argument, you can tell that, okay, prevent destroy equal to true. Then what happens here? It is going to, okay, stop you from deleting. So even though you say Terraform destroy, that will not be deleted. So that is useful when you are accidentally deleting some critical resources like database servers and app servers, web servers. When you accidentally delete, okay, if you don't want to delete that, then you can write a life cycle in the my life cycle meta argument. You can add a argument like prevent destroy equal to true and create before destroy. Generally, when you execute the Terraform destroy command, what happens here? Normally, first resource will be destroyed and then it will be recreated. And if you want to reverse the task, like create before so if you want to create a resource, then you wanted to destroy it, then you can add a argument called create before destroy equal to true. Create before destroy equal to true. Okay. Now let us look at one document here. Terraform lifecycle. So I am going to give link of this document, space lift. Okay, this is a document which is going to show all the necessary things. Refer here. And here it is going to explain Terraform lifecycle meta argument very clearly. Okay, destroy and create. And here this is lifecycle meta argument. So in the lifecycle meta argument, I have given something like ignore changes equal to true. And if someone changes some properties, and when you reapply this, Terraform does not take care of it. Okay, it will ignore the changes. So if you want to ignore everything, hello.
Yeah, yeah, I can hear you.
Okay, I have confirmed you previously, but no one is you are not responding. Okay.
Oh, sorry. So I was on meeting and attending the office meeting. So that's it. So yeah, I can hear you. Sure.
Okay. Okay. So are you following completely? Are you watching? So have you watched this example?
Yes, Shiva.
IAM user creation.
Yes, Shiva. Yeah.
Okay, okay. And so here in the life cycle meta argument, so you can write a argument like create before destroy. So when you add it, what happens here? Before Terraform destroy a resource, first of all, it is going to create, then it is going to be destroyed.
Okay.
Okay, so this is going to reduce downtime. This is going to reduce downtime. And
Okay.
suppose there is a critical database server, and if you prevent from deleting the resource, then you can use a meta argument called prevent destroy equal to true. Generally this is useful for database servers. So if you accidentally delete a server and if you don't want to do that, then you can add this prevent destroy equal to true.
So that is specific to only the databases.
No, you can add to anyone. You
Anyone.
can
Okay.
add this meta argument to anyone. Okay, but
Okay.
the thing is, so if you write this argument, what happens here, you cannot delete the resource.
Okay.
And when you execute Terraform destroy command, okay, that particular resource will not be deleted. Generally this is useful when you accidentally delete database server, and when you accidentally delete database server, it does not permit you.
Okay. Gotcha. Okay.
And here ignore changes means whenever Terraform finds some changes in this tags department tag, okay, so it is going to ignore. So generally if you don't write this, what happens here, if the tags are changed here and according to your configuration, the infrastructure will be modified. And when you add this, what happens here, even Terraform finds a difference in department tag, that will be ignored.
Okay.
And this is also one of the important life cycle precondition and post condition. Precondition is going to make sure that, okay, before creating a resource, it is going to ensure, suppose here in the precondition I have written a condition like data dot, it is going to verify whether the web server infrastructure, web server type is x86 underscore 64. If it is x86 underscore 64, then only, okay, so it is going to permit you to create AWS instance. Otherwise, it is not possible.
Okay. Okay.
And we have many examples here.
Okay.
And this is also one good example. And here is creating a resource group.
Okay.
Okay, so in the resource group he has written a life cycle rule. Okay, generally life cycle meta argument can be written in any of the resources, like in any resource group or virtual machine network, in any resource group, in any resource, you can write life cycle meta argument. Prevent destroy equal to true means, okay, so you are not permitted to delete this resource group.
Research. Okay. Okay. Got it. Okay. So basically, life cycle is the method function, right?
Yes, it is a meta argument
Meta argument. Okay.
which you can include, okay, in any of the resource.
Research. Okay.
Now we are going to discuss one more important thing. This is a random string. So when you want to generate some strings randomly, suppose I want to create 5 virtual machines. For every virtual machine, I want to give some random names. I want to generate some random names. Okay. So to give random names to my virtual machines as tags, I need not to manually give any random strings here. Okay, here in a Terraform, we have a resource called random string, which is going to generate some random strings. And at the time of creating random strings, you can specify how many strings you wanted to generate and with what combination you wanted to create a random string, like whether you want to create a random string with uppercase letters or lowercase letters or digits, special characters, and that random string you can assign to a virtual machine or to any other resource. Now let us look at this one small example, and we will create it. And this is random string resource block creation and a resource. Okay, first let us see how to create random string. First, Terraform random string. And this is random string creation block here. So what are the arguments we need to supply? Length. Okay, with how many characters you wanted to generate random string. Whether you want to use special characters or not.
Okay.
And lower means whether you want to use lowercase characters in the random string. And
Okay.
whether you want to use uppercase letters and whether you want to use special characters or not.
Okay.
So these are the arguments here. And there is one more argument called count, and how many random strings you want to generate. Count is there. Here count, where is count? Okay, so count means it is a meta argument and that will be repeated that for those many times here. Now let us look at one example here. Here, length equal to 16, default random string. And here in the second random string, in the second resource, we are generating only uppercase letters. Upper length equal to 16, upper equal to true means uppercase letters are existing. Uppercase
Okay.
letters will be there in the random string. Lower equal to false, number equal to false, special equal to false. Only random string will be generated with uppercase letters.
Okay.
And in the second case, lower. So here I am doing upper equal to false, lower equal to true only. Number equal to false, false, special equal to false. And this is a random string with numbers here. Number equal to true, special equal to false, upper equal to false, length equal to 16. And this string is going to generate only special characters. Random string will be forming with special characters, special equal to true. And we are using all these strings in the instance creation. And we are giving all these random strings to my tag instance tags. So tags equal to type equal to Terraform, random default. Okay, we are using these random string dot default dot result, and whatever result that is generated by this default will be added here. In the same way, number dot result, upper dot result, lower dot result, special dot result. Let us exactly copy paste this. Let us generate it. Copy this. And inputs also I am going to comment it. IAM I'm going to write pm.tf or pm, right, random.tf. Let us validate this. Terraform validate. This thing required provider. Here, tags are not expected here. Did you mean define arguments tags? Okay. The meaning of this one. While creating Terraform, AWS EC2 instance. Why it is not permitting tags? Access key. Okay, these are warnings only, not errors. Number equal to for this is deprecated. Use numeric. Okay, is asking to random. Numeric equal to false. Okay, done. Now let us apply it. Terraform, apply, auto up. Okay, image ID does not exist. Okay, we have to take care of image ID, right? And here go to EC2 black, EC2 section, launch instance, Ubuntu, copy this, what is this? Okay, we have to we are not using invalid key pair. Okay, let us create a key. EC2 and here key pairs. Create key pair 0 John Terraform. This PEM file. Okay, one resource was created. Let us go and verify whether tags are created or not. EC2 and one machine is running here. Here, if you go and verify in tag section, you are seeing tags right here.
Yes. Random type.
Type equal to Terraform numbers. Okay. So here a random string was generated with only numbers. Random default, random lower, random string, and the random with uppercase letters, random with numbers, random with default 60 characters will be there,
Right.
and random with lowercase letters,
Yes.
random with
Special
string,
character.
special characters.
Yeah.
So this count is not required actually because we are creating only one. So count is not required. Let us just try this. So is it clear, Mahinder, so far?
Yes, Shiva.
So with this, our Terraform with two clouds are completed, and tomorrow we will start Python. Okay, Python fundamentals for 2 weeks. Then I will
Okay.
show how to create resources with Python in AWS.
Okay. Sure, Shiva. So Shiva,
And
you said like,
tomorrow,
uh-huh.
and can we make it 30 minutes earlier from tomorrow onwards?
Yeah, sure. So in 8 o'clock, right?
30 minutes earlier means 8
Okay.
o'clock. 8 o'clock means if you are in Eastern zone, it is your, I think,
9.
9:30 a.m., right?
Yes, 9:30 a.m. Yeah, it works.
9:30.
Okay, it works, Shiva, for me.
Okay. And I will share all these notes in the drive and
Uh-huh.
go and practice. If you have any questions, you can ask in the next class. Okay.
Sure, Shiva. Shiva. So from
Yeah.
next week I won't be available, Shiva. So
Okay. From next week onwards.
yeah, ఈ ఫ్రైడే వరకు అటెండ్ అవుతాను.
Hmm.
సో ఇమీడియట్గా ఏంటంటే లైక్ మెడికల్ ఎమర్జెన్సీ ఉంది ఇండియాలో. సో నేను సాటర్డే మార్నింగ్ ఇండియాకి ట్రావెల్ చేస్తున్నాను.
Okay. Medical emergency మీకా? ఓ మీ
లేదు, మా మమ్మీకి. సో తను
ఓకే
ఇప్పుడు
ఓకే ఓకే
తను ఇప్పుడు ఐసీలో ఉంది. సో నేను నెక్స్ట్ 2 వీక్స్ ఇండియాలోనే ఉంటున్నాను. సో
ఓకే ఓకే
అటెండ్ అవ్వలేను ఇంకా. అటెండ్ అవ్వలేను. సో
ఓకే
అది
ఓకే అంటే రికార్డింగ్స్ ఎలాగో వస్తాయి మీకు రికార్డింగ్ షేర్ చేస్తాం లేండి
ఓకే ఓకే షూర్. యా షూర్.
అదే సేమ్ డ్రైవ్ లో రికార్డింగ్స్ ఉంటాయి
ఓకే
ఓకే ఓకే ఓకే
షూర్. యా ఇన్ కేస్ లైక్ మిమ్మల్ని రీచ్ అవ్వాలి అనుకుంటే ఇప్పుడని కాదు, ఫ్యూచర్లో ఏమన్నా రీచ్ అవ్వాలనుకుంటే ఎలా శివ?
మీకు మెయిల్ ఐడి ఉంది కదా, మెయిల్ ఐడికి మీ నంబర్ ఫార్వర్డ్ చేయండి, నేను కూడా ఫార్వర్డ్ చేస్తాను.
ఓకే ఓకే శివ. యా
వాట్సాప్ నెంబర్ ఫార్వర్డ్ చేయండి. ఓకే
ఓకే. మీది మెయిల్ ఐడి ఏంటి శివ?
మెయిల్ ఐడి మీకు రికార్డింగ్స్ వస్తున్నాయి కదా డైలీ, అదే మా నా మెయిల్ ఐడి.
అదేనా? ఓకే. యా నేను దుర్గా సాఫ్ట్ అనుకుంటున్నాను, అది కాదు. ఓకే ఓకే.
లేదు లేదు, కుమ్రవెల్లి శివకుమార్ డెవాప్స్ అని ఉంది కదా డ్రైవ్ నేమ్.
అవును, డ్రైవ్ నేమ్. యా
నేను రాస్తాను, ఇక్కడ రాస్తాను, ఒక్క నిమిషం.
ఓకే శివ.
మెయిల్ ఐడి.
ఓకే శివ. యా థ్యాంక్ యూ శివ.
అంటే ఈ ఫ్రైడే వరకు అవైలబుల్ ఉంటారు మీరు, సాటర్డే నుంచి అవైలబుల్ ఉంటారా?
సాటర్డే నుండి ఉన్నాను శివ.
ఓకే ఓకే రైట్.
సో నేను 2 వీక్స్ ఉంటాను అక్కడే. సో ఇంకా హోప్ఫుల్లీ ఎవ్రీథింగ్ గోస్ గుడ్ అయితే బ్యాక్ వస్తాను, లేదు అంటే ఇంకా స్టిల్ అక్కడే ఉంటాను కొన్ని రోజులు. బట్ అల్
ఓకే. ఎక్కడ మీది? హైదరాబాదా? ఎక్కడ?
ప్రాపర్ వచ్చి సిద్దిపేట.
సిద్దిపేట. ఓకే ఓకే.
సిద్దిపేట ప్రాపర్ వచ్చి సిద్దిపేట. బట్ ఇప్పుడు ట్రీట్మెంట్ అంతా హైదరాబాద్లో అవుతుంది.
ఓకే 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 సరే. మీకు ఎలాగో డ్రైవ్ లో రికార్డింగ్స్ ఉంటాయి, మీరు షేర్ చేసుకోవచ్చు. అప్ టు 1 year మీకు అవైలబుల్ ఉంటాయి రికార్డ్స్.
ఓకే థ్యాంక్స్ శివ.
ఓకే
ఓకే థ్యాంక్స్ శివ.
టుమారో ఎప్పుడు మనకి 9:30 రేపు, టుమారో 9:30.
ఓకే 9:30 AM. పర్ఫెక్ట్.
Yes.
థ్యాంక్స్.
Okay, I'm stopping the session.
ఓకే థ్యాంక్స్ శివ. యా